Okay, so just in the past video I have the router connected to a switch, connected to end devices, and all of them received the required information and lived happily ever after. But imagine the upcoming scenario. You are the network administrator of a building. This building contains a company, a small network for whatever reason, a bank. Anyway, it's a network. And in this building there are some multiple stories, and by stories I mean floors. Each one of them represents a department or a division. So there will be employees in every one of them, in each one of these departments, etc., etc., all of them. There will be a switch for each department, and maybe for some reasons there will be a router also for every department. Okay, so far. And there is a main, which is the strongest and has the biggest resources router, maybe in the ground floor, in the main department, and all of those lovely brothers connected to it. So every morning or whenever a shift starts, all of these devices in these floors will require IP addresses, and of course we will use DHCP as a requirement to offer the IP addresses, subnet mask, default gateway DNS, and so on. So the concept of DHCP, and also maybe in this scenario also from floor 1 to floor 4, from the second floor, not floor 1, these floors except for the ground floor, all of them has some simple router, some simple cheap router just to do things for routing, and that's it. No other functions and responsibilities for it, because it will have high utilization in CPU and RAM. No problem. I will place my DHCP server in only a single router, and this makes sense. It doesn't mean that whenever I see a router in a company, so this router has a DHCP address server, and also this one and this one, all the routers have DHCP servers. This is overload for the resources and doesn't make sense, because having only one router in the network, since it's a small network or a medium-sized network, and this one do offer DHCP and IP addresses for all the networks, will be good enough, and it will manage whatever happening and the customization and organizing your IP addresses and information between all the departments and devices. Okay, so I agree with you, sorry, to make this router in here the strongest router as a DHCP server. Okay, so agreed until now. But the big problem is that this end device, when it requires an IP address, what will it send? 2 videos ago we take that it will be DHCP discover message, and the DHCP discover message is a broadcast message. This broadcast message, when it will go from this computer starting, it will first reach the switch. You know, switches, they float everything, they flood everything, they don't make anything stop, so they will flood the broadcast message to this router. What will this router do is that it will take this broadcast message that is requiring IP addresses, and the router will say, well, I do not offer IP addresses, so this message is meaningless to me, please drop it. And it will drop it, because routers are not switches, they do not forward broadcast messages by default. And this is a disaster, because all the other stories, all the other floors will not receive IP addresses, all their end devices will not receive IP addresses. Only maybe the ground floor, because maybe the pool will be in here and all the devices in here will receive IP addresses. But what about the other 4 floors? What will happen to these departments and end devices? They will receive nothing. because broadcast message, okay, you cannot manipulate this. This is a broadcast message. The DHCP discover is a broadcast message, and it will always be a broadcast message. What should I do? Okay, because this router in here, there is a router in here. I don't want to change the design of the network. I'm a network engineer. I must give multiple solutions, not to change the already established design. I must make use of it. Okay, and I'm not a magician, because network and technology do help me in this. They do assist me in this. Scientists, organizations, and developers do always try to help us and make using of all the available scenarios and might be available scenarios in networks. Okay, so there is a router in here. I cannot change that, but I must make this router do forward this broadcast message to the main router, telling it that I have received a broadcast message. It's a DHCP discover. I think it belongs to you, because they said that you have a DHCP pool inside you, and this one exactly will reply with the offer. After that, again, the DHCP request, which is also broadcast message, will reach here, go again to this one, requesting a DHCP information, and the reply or the pack will go back again to the end device. All of this is done by using another method or a new technology that's derived from the DHCP technology called the DHCP relay. DHCP relay is telling this specific interface in here. Okay, things are becoming, okay, it's a small battle in here. Okay, I will just show it in the lab more accurately. Okay, so this interface, that's the first interface receiving the broadcast message. Which interface you might think of is the first router interface that will have a face-to-face conflict with the broadcast message coming from an end device, the default gateway interface. Okay, so I will make this default gateway, and I will tell it, whenever you receive a broadcast message, please, asking for DHCP information, please forward it immediately to this router in here. Okay, to this specific router in here, so that this router will reply back to me. This case you will use when your DHCP server is not in the first router that your end devices will get attached to or will talk to. Okay, so this is the benefit of the DHCP relay technology. It will be done and applied in the upcoming lab just in a few moments. It will help redirecting the broadcast message from the first gateway to the correct server. There will be a helper address. This is the command that you will use in the technology of the DHCP relay. Okay, just in case the gateway wasn't a DHCP server. Okay, so no more talking. Let's just go and build a lab for us. Okay, so in the lab, what I will have, that there will be, let's make it only 3 end devices in here. The 3 of them are connected to a switch. This switch is connected to a router, and unfortunately the router is not the DHCP server. So my connections should be this way, also this way, also this way. Okay, so this will be my topology. Okay, so for the networks that I will use, okay, of course, so you should now have known by default this router is connected to 2 links. So these are 2 networks, a network between router 1 and 2, and the network between this router, the department router, and the department devices. So I'll have 2 networks. The first one should be 192.168.10.0. Let's make it /109. Let's make use of our subnetting skills. And the other one in here, it will be 192.168.10.10. What 10 you are talking about? Let's make it .20.0, and it will be /28. Okay, so I hope this is clear to you on the screen. No config for the end devices. DHCP should do that. No config for the switch. It's only a switch. We need nothing. What we will configure is these two routers. So the first thing, I will configure these two routers. This router in here, sorry. No, of course. Enable configure terminal. I have two interfaces. All what I will do in this router, only IP addresses for the two interfaces. That's it. Only. As simple as that. Okay. So the first interface, which is fast Ethernet 00, give it an IP address of this network 192.168.20. Let's make it .1, and the subnet mask for 28 will be, I think we have time just to do quick subnetting. 28 means that it's more than 24 by 4 numbers. Okay, after 24 and using 24 I have 255, 255, 255 and 4 ones, because these are 8 ones in this way, and here I have 4 ones. These 4 ones will be 128 plus 64 plus 32 plus 16 plus 4 zeros, so this will be 129, 224, 240. So doing mathematics, this will be 240. Okay, so this is slash 28. So 255, 255, 255, 248, 240, I'm sorry. Hit enter and no shutdown. That's it. Exit. That's all I need for fast Ethernet 00. For fast Ethernet 01, I will give it the IP address of, let's make it 192.168.10.1 also, but again we will do subnetting for slash 29. 29 is 5 ones more than the 24, and I know 24 do give me 255, 25, 255. So in this way I have now 5 and these 5, so let's make this one as 1. These are 5 ones, 3 zeros, so 128 plus 64 plus 32 plus 16 plus 8 plus zeros, so it will be 240 plus 8, so 248. If I was doing this by skipping and doing this very quickly, and you can get it, studying subnetting will make you do this automatically and in the same fast way that I'm doing. Okay, because subnetting is very important to do it like 100 times by yourself. So 255, 255, 255, 248. This is the subnet mask of slash 29. No shutdown, and yes, and exit. That's it. Exit again. No other config should be done to this router. Now let's just clear the screen. Go to this good device in here. Give no. Enable config T. Now interface fast Ethernet 0/0. Let's give it the IP address of 192.168.10.2, and I believe it was just a few moments, 248, which is for slash 29. No shutdown, please. Okay, now everything is up. Just like the previous lab, we will do the DHCP config. So IP DHCP create a pool, call it III dash relay. Okay, so the network will be which network? 192.168.10 or .20? Be careful. These devices are in this network. All of this broadcast domain belongs to this network. So I will not type in here this network. Be careful. The network that I will type right now will be the network that its IP addresses should be distributed to the devices, to these devices, and these devices should have this network as agreed for the topology. So 192.168.20, and be careful with the subnet mask. It will be 255.255.255.240 only. Please be careful. Okay, first thing. The other thing is that the default gateway for these devices, what it will be. The default gateway for these devices, it should be the interface of the first router that will receive a broadcast message from them, and this interface of this router have the IP address of 192.168.21. Okay, so please don't mix your cards, don't get confused. This should be enough. Let's give it a DNS server like for 8. It's a public, and for 3 DNS server exit. And yes, please don't forget that IP DHCP excluded address like the previous lab should be the default gateway IP address that I don't want it to be distributed to anyone or giving to any end device requesting. Exit. So what I have done right now is that I am making all these devices obtaining an IP address subnet mask default gateway and DNS from this pool that I have just created, and name it the pool of III-relay. Okay, so for now the DHCP pool is in here. What's happening is that whenever these devices send a broadcast message to this one, this router will forward it to this one, and just to check if this router can forward a message to this router, then it will be happened if they are reachable, both of them. Okay, so if this device can reach this device, then it will be happened. So ping 192.168.10.2, is it reachable or not? Yes, it's reachable. Can I specify a source? No. Okay, so that's it, no problem. Okay, so if I right now make these devices requesting a DHCP, will they receive the info or not? Since now there is already a DHCP server. Requesting failed. DHCP failed. A PIPA is being used. The automatic private IP addressing is being used, which is 169 of Microsoft. You remember it? We have talked about it in chapter 1. Okay, why did that? Because when this is the default behavior, this device sent a broadcast message to this router. Reaching this router, the first thing that this router did for the broadcast message, it was requesting DHCP information, and this router said that I don't offer DHCP, so just discard this. What we should do in the DHCP relay is that we should inform this interface, this exact specific interface, whenever you receive a DHCP request as a broadcast message, please forward it to this device, and this device will complete the mission, the job. Okay, so go to this router. Now I will do one single command only. Okay, config T, which interface receive the broadcast. It's fast ethernet 00, so interface fast ethernet 00. This command will be IP helper address. Whenever you receive a broadcast message, please send it to this device. How to make this device do direct or do know which device I'm talking about? By entering an IP address of this device, and the IP address of this device will be of this interface, which will be 192.168.10.2. so 192.168.10.2, and that is all I need, and that's it, as simple as that. So if this device again did send a broadcast message to this interface, it will be redirected again to this router in here, which do carry DHCP information. Let's try our luck. Let's see if all our config is correct. Now click the DHCP again, request again, waiting again, please. No, it did not work. One third time. Why it would not work? Not this one. Okay. I believe something is missing. It failed. Why it did failed? Okay, does this switch? Can this switch ping this device or not? Let's do enable. I believe I have just remembered what I have forgotten. No, that's why the devices cannot send it, because reachability is missing. And to obtain reachability between these two devices, for this interface to reach this one, because these are two different broadcast domains, I need routing. So I will use OSPF between these two devices. Okay, so let's add OSPF, config T, router OSPF, process ID 1, identify network 192.168.10.0, which has the wildcard mask of 248.255 minus 248. How much will it be? Do that faster than me. I challenge you. Okay, 255 minus 248, and that should be 7. Okay, so 0.0.0.7 area 0, and also identify 192.168.20.0.0.0.0 and slash 28 was 40, so 15 area 0. Okay, so exit, and let's take these two, copy, and go here, try to paste it in the config. Okay, chill down, come on, I will do it by myself. Okay, so router OSPF1 network 192.168.10.0, it was 7, yes, area 0. I don't need to identify the other network, this will be useless. Okay, and let's wait for the adjacency. Yes, it's full now. This switch that wasn't able to ping that device, will it ping now? Please. Maybe because I haven't identified an IP address in here. No problem. Let's try one last shot of luck. Oh, already done. Okay, 192.168.20.9. This device have received it with this subnet mask and default gateway. The other one, let's do it again, and it's already, please re-request, let's change it. Okay, again it did receive all the information. The third desktop, let's try for the third time, please. Yes, it did receive the information correctly. Just one last shot. Let's try a server, because you know servers are end devices and they should do the same behavior of a desktop. So click in here, go to this desktop of a server, do make it a DHCP, let's wait for it, and the server should obtain everything normally and correctly like the other. So the lag, what we were missing, what I have forgot to config, was routing protocol, because this is a broadcast domain different than this broadcast domain, so both of them will not by default become reachable or be reachable and be able to communicate together. We will need routing protocol. I was just about to finish it. Was this necessary? Okay, sorry. Anyway, so this is the concept and practice hands-on lab for DHCP relay. Don't forget DHCP config, IP helper address for the front-facing router, and routing. Don't forget routing like I did right now. Okay, so I hope all of this was informative for you. Please, if you were new to our channel, subscribing the channel and liking the video will be very kind of you. This is more than enough like a thank for me if I was doing good and informing you well. Okay, this is the end of the DHCP technology. Not really. I will mention DHCP again in chapter 5, and you will see when for something very critical and important. After this, we will start a new subject for chapter 4. Please stay tuned with us and follow us after you study DHCP well. Thank you for watching and for your time, and goodbye.